Have you ever really thought about the hidden intelligence humming away under the hood of your car? It's kind of wild, but every modern vehicle has a powerful computer making millions of decisions every single second. So let's dive in and uncover this unseen brain that's really running the show. It all starts with something we've all seen. And yeah, maybe dreaded a little bit, the check engine light. We've all had that moment, right? You're just driving along and boom, there it is. This little light is actually our way in. It's a signal from the very brain we're talking about. But what's it really trying to tell you? I mean, this light is just the public face of a much, much more complex system. So it really makes you wonder, what is this brain that's monitoring everything and decides, okay, time to turn on the light? Well, that brain is called the ECU, which stands for Engine Control Unit. You might also hear it called an ECM or Engine Control Module. Don't worry, they're the exact same thing. Just think of it as the central command for your engine. Its whole job is to manage performance, fuel efficiency, and emissions, all in real time. Okay, so how does this brain actually work? Well, at its very core, it's running on a really simple but super continuous loop. Input, process, and output. Let's break that down. First up, inputs. You can think of these as the ECU's senses. It's constantly gathering data from this whole network of sensors scattered all over the engine. These things are measuring everything, and I mean everything, from your engine speed to the air temperature to how hard you're pressing the gas pedal, even the oxygen levels in your exhaust. And this diagram here, it just lays out that loop perfectly. You see, all that information from the sensors provides the input. The ECU then takes this massive stream of data and processes it, running it through some seriously complex software to figure out what to do next. And that brings us to the final step, the outputs. This is the action part. After processing all that data, the ECU sends out precise commands to a bunch of things called actuators. These are the parts that do the actual work, like telling the fuel injectors exactly how much fuel to spray, or controlling the spark plug timing, all to keep the engine running absolutely perfectly. So that's the big idea, right? But what does this brain actually look like? Let's go from the concept to the real-world hardware that's making all this magic happen. And wow, this slide really puts it into perspective. On the left, you've got the simple diagram of how it all works. But on the right, that's the real deal. That's the actual circuit board from something called a FADEC. It's a super advanced ECU they use in jet engines. And we're looking at that because, in a jet, failure is just not an option. So these systems are the absolute peak of reliability. So when you get right down to it, inside that little metal box is a seriously powerful microcomputer. It's got a processor, it's got memory, all on a circuit board, running software that's making millions upon millions of calculations every single second you're on the road. But, it wasn't always this slick. Early on, engines had this clumsy collection of separate, mostly mechanical parts trying to do all this. The real game changer was when we started integrating all of those jobs into one single digital system. And you can really see that evolution here. On the left, that's the old way, a bunch of separate mechanical bits and pieces that couldn't even talk to each other. But on the right, that's today, a single digital brain managing the whole shebang in perfect harmony. And that integration, that's what allows for the kind of non-stop, real-time adjustments that were just impossible before. This quote just sums it up perfectly. The key phrase to focus on is in one package. Instead of trying to get a dozen different parts to play nicely together, everything is designed from the get-go to work as one seamless system. All right, so we went from a bunch of separate parts to one integrated brain. But so what? Why does any of this matter to you when you're just trying to get from A to B? What's the real payoff? Well, the benefits are huge. This one brain squeezes out more power for better performance, while also making sure you get the most out of every single drop of fuel, which saves you money. At the exact same time, it's constantly adjusting things to keep pollution incredibly low. And maybe the coolest part, it gives the car the ability to diagnose its own problems. And that leads us to one of its most powerful features, something called onboard diagnostics, or OBD. When the ECU senses something isn't right, like, say, a tiny little leak in the fuel vapor system, it doesn't just turn on that light. It actually logs a super specific error message called a diagnostic trouble code, or DTC. A code like P0442 is a perfect example. And these codes, they're not just random numbers, they're a language. Let's decode P0442 together. The P tells us the problem is in the powertrain. The 0 means it's a standard, generic code for all cars. The 4 points us to the emission system. And finally, the 42 pinpoints the exact problem, a small leak. The ECU isn't just saying, hey, something's wrong. It's telling the mechanic exactly where to start looking. Pretty smart, huh? So, from a simple warning light to a complex diagnostic language, the ECU is truly the silent hero working under the hood. And it leaves us with a pretty fascinating question to think about. As our cars basically become rolling computers, what's next? As these brains get smarter and more connected, what will they learn to do next? Will they not just diagnose problems, but maybe even predict them before they ever happen?